we're going to do is we're going to look at the periodic table. Now, the periodic table lists all of the known elements in that we know of. Okay, the elements in the periodic table are listed in order of increasing number of protons in their atoms. Okay, and the number of protons an atom has, as we talked about, is called my atomic number. Now, each element has a certain amount of information in the box in their area of the periodic table. So, in their upper corner of the box, we have our atomic number. And our atomic number is the number of protons in the nucleus, and it tells us the atom. We also have our element symbol. Now, all element symbols have at least one capital, and if they have two letters, then the second letter is lowercase. So, for example, in the place of argon, the A is capital and the R is lowercase. We have obviously our chemical name. And then the last piece of information is usually placed under the symbol or name is our atomic mass. And this is the mass of one of the atoms. And because electrons are massless, my atomic mass is equal to my number of protons plus my number of neutrons, as we talked about. Now, each row of the periodic table is called a period. Okay, and all the elements in the same row are said to be in the same period, but they can be very different from each other, especially in terms of their chemical properties. Each of the elements in the columns, though, because they have a similar electron arrangement, they behave similarly, and so we call them a group or family because they behave. Okay? And elements in the same group have similar chemical properties and some physical properties. Okay? And the reason is that all the elements in a group or in a column, each atom has the same number of electrons in their outermost orbit. And we'll talk about what this means tomorrow. Okay? Now, when we look at our periodic table, we now have our rows, which are called periods. We can classify them in their groups as families or groups. And then we can also classify them as metals, nonmetals, or metalloids. Now, when we look at our periodic table, we can see our chemical families. And there are some families that we will be interested in their name. And so what we're going to do is we're going to take our time to color them. And so our first group, group 1, which is the first column in the periodic table, these are called our alkali metals. Now, when we look at our alkali metals, we want to remember that hydrogen is not an alkali metal, but we'll continue from lithium on downwards. And so we'll color all of these the same color. Now, don't color them so much that you can't see what they are. Okay. Then our second group, group 2, are our alkaline earth metals. And they're called this because of how they react with water and also because they're found in the crust. Okay. Then another group that we're interested in is group 17, the 17th column. And these are our halogens, another group that's very reactive. And then we have our group 18, which is our noble gases. And these things are the least reactive elements. Then finally, we can look at a couple other things. We have our transition metals, which go from they're the short columns, the elements in the short columns in the middle. Okay, then we can see this bold line here in the periodic table. This bold line helps to define the periodic table into our two broad categories of we have our metals to the left of that line, we have our non-metals to the right of the line, and then we have a group of elements who touch the line. Oh, I should pick a different color, sorry. These elements here that touch the line, these are metalloids. Okay. So when we now look at our different compounds, our metals, we know they're all solids at room temperature. They're all ductile. They can be drawn into a wire. They're shiny. So we say they have luster. They can be hammered into shapes. So they're malleable. They conduct heat and electricity. And we have a wide variety of examples. Common examples that people know about would be things like gold, AU, iron, Fe, or copper, Cu. Okay, then our nonmetals, they can be solids, liquids, or even a gas at room temperature. If they were a solid and we hit them with a hammer, they'd shatter, so they're brittle. They're dull in color as a solid. They are not malleable. Oh, sorry, brittle goes under malleability. And they're not ductile. They cannot be drawn into a wire. Okay, and they're poor conductors of heat and electricity. And some examples of them might be oxygen. We can also have chlorine, or we can have phosphorus. Okay, and so they have their different properties. In the middle, between the two of these, we have our elements that are a mixture, and they can be shiny. They're all solid at room temperature. They can be shiny, but most of them are dull. They're not ductile, with the exception of aluminum. Some of them can be hammered, but most are brittle. Okay. And they're poor conductors. And they include things like silicon, which we use to make computer chips.